Okay, so the first example here is one where we can just use this equation right out of the box, right? Battery with an EMF of 6 volts, right? So that's this guy. Okay, has an internal resistance of 0.145 ohms. What current flows when it is connected to a light bulb with a resistance of 3.6 ohms? That's this, right? And then we're solving for the current. It's like, ooh, I think I can do this, right? This is kind of contrived because most problems are harder than this, okay? So we just plug this in, right? EMF is equal to I times R plus, so that's the external resistance plus the internal resistance, right? So 6.00 equals the current that we don't know. And then it's 3.6 is the external resistance plus 0.145 is the internal. And so literally I'm just going to divide by 6 by 3.745, right? Okay. 6 divided by left parenthesis 3.6 plus 0.145. And I get 1.602 amps. So I would say 1.60 amps. That's the current that flows, right? What is the voltage across the light bulb? Well, to find the voltage across the light bulb, I would use Ohm's law, right? V is IR. Okay, so that's going to be 1.602136, all of that precision, right? That's the current flowing through this guy, right? This is just a series circuit, right? We know how to do this. And then this is only 3.6 ohms, right? All right. So I multiply that. I go boom times 3.6. And I get 5, that voltage is 5.76769 volts. So that would be about 5.77 volts. Is that right? And you can see that the phenomenon, right? It's a 6-volt battery. If you hook a voltmeter to it, it's going to read 6 volts. But when you hook that light bulb to it, the potential is going to drop to 5.77 volts. And that's because the voltage drops across this resistor, okay? And it drops, we could figure out it drops 0.23 volts, right? Okay? So let's look at some other examples here. The next 2 examples, it's not going to tell you everything that's in this, and we got to scratch our head a little, okay?